Okay, so you just did your bell ringer, and now we're going to move on to our direct instruction. So pull up your guided notes, and what are we going to talk about today? Today it says, I can create a model of the rock cycle. Now I know what you're thinking. Wow, rocks. That cannot be exciting, but I swear, bear with me, it's cooler than you think it's going to be. Trust me. And I think you might have already started all of this with Miss Maholtra last year. I'm 93% sure about that. So hopefully this is going to sound familiar, and today's honestly not going to be too tough. So let's dive into it. So first, what the heck are even rocks? So rocks are naturally occurring solid mixtures made of minerals and just smaller rock fragments. So we've all seen a rock, I hope. This is some pretty cool looking rocks. And honestly, everything that is the Earth's surface is at one point or another a rock or is about to become a rock. Maybe you haven't thought about it that way, but it's true. So we should be familiar with rocks. Now, rocks aren't going to stay the same forever and ever and ever. How did they even form and what are they going to turn into? That is exactly what we're going to talk about today. So there are a ton and a ton of different processes that can occur that can form a rock or change one type of rock into another type of rock, and we're going to break that down. And all of that process, all of those cycles, we call that the rock cycle. So it's just a series of processes that can change one type of rock to another type of rock. So there are three types of rocks that we're going to talk about. We have sedimentary rocks, metamorphic rocks, and igneous rocks. So before we dive into that though, what even is a cycle? Because maybe you've seen or talked about different types of cycles in your science classes before. There's the rock cycle, duh. There's also like the water cycle, there's the carbon cycle, nitrogen cycle. There's all kinds of cycles that if you haven't learned any of them yet, you will in the future. And all cycles pretty much work the same. It's just what's in the actual cycle is going to change. So, what do I mean by that? So, if you're looking at a cycle, what you always want to focus on, always, 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 is the arrows. Because everything that the arrows are pointing to and from, and everything written on the arrows, is going to give you all of the answers and all of the information that you need. So even just looking at this cycle, even though maybe you've never seen it before, if you can read this cycle and know how to read a cycle, you pretty much know everything you need to know. So how do we read this? So looking at the arrows, first, each arrow is going to be pointing from something to another thing. So whatever that arrow is pointing from, it's pointing from what it's starting as and pointing to what that item is going to become. So if we look down here, we've got a sedimentary rock, and here we have an arrow pointing from that type of rock to a metamorphic rock. So if we're thinking about this part of the cycle, we're just talking about a sedimentary rock becoming a metamorphic rock. That's all that the arrow is telling us. Also, and this is probably the most important part, written on or beside the arrows is going to explain how that item is becoming another item. So if we look at the sedimentary rock, we have the arrow pointing to the metamorphic, so it's becoming metamorphic, but on that arrow it says heat and pressure. So we know that the sedimentary rock is becoming the metamorphic rock by heat and pressure. So whatever is written on the arrow is telling you how one thing is becoming another. And like I said, we're going to break down like what even is sedimentary rock, why does it become a metamorphic rock? We're about to talk about that. So if you're like, Miss Long, chill with these new words, no worries, we'll break it down. So always, always, always focus on those arrows because they tell you everything you need to know. Now, the cycle has to be driven by something. Something has to cause these rocks to change because you and I both know that change is hard and it's much easier to just stay the same, right? So something has to drive the cycle and make it happen. So there are three things that are going to drive the cycle. That is going to be temperature, pressure, and weathering. We know temperature. We know pressure. Weathering might be a new word for us, but we're going to learn it today, so no worries. So temperature, pressure, and weathering is going to drive this cycle. It's what's going to cause it to happen. Okay, enough about that. Let's actually talk about the rocks, shall we? So like I said, we have 3 different types of rocks. The first type of rock that I want to focus on is that sedimentary rock. Sedimentary. So what is a sedimentary rock? So this is a type of rock that is going to form when tiny minerals or sediment from older rocks get pressed or cemented together. Okay, what does that mean? So sediment is just a fancy way of saying dirt or sand. So we know dirt, we know sand, we've seen it, we've touched it, we've been around it. It's those little teeny tiny grains. So what's going to happen is a bunch of that dirt and a bunch of that sand is going to layer on top of each other, and they are going to eventually be pressed and cemented together until they form a solid rock. So before I move on, you'll see over here when I'm talking about these 3 different types of rocks, I'm going to slowly walk us through this rock cycle so you can see it part by part, piece by piece, so you know exactly what's going on. So here we have sediment, right? Like I said, dirt or sand. So again, focus on those arrows. For sediment to become sedimentary rock, so we're looking from sediment and the arrow is pointing to sedimentary rock, we need what's called compaction and cementation. When you see things, or when you see the word compaction, you might know the word compact. That just means things are tightly together. Or we know what cement is, right? If you go outside and walk on the sidewalk, you're stepping on cement. That's that hard structure. That's all of those pieces of sediment pushed together. It's kind of, think of it as it's like glued together. So compaction and cementation is just the squeezing and gluing of those minerals and sediment. So basically you're going to have sediments go through compaction and cementation because it's written on the arrow, and that is how they're going to turn into sedimentary rock. Now, one big fancy word I want to throw at you. Sometimes you might not hear the words compaction and cementation. They might throw a different term at you called lithification. Lithification. It kind of sounds like you have a lisp when you say it. Lithification. So if you see compaction, cementation, or lithification, know that we're talking about sediments becoming sedimentary rock. Okay, now what's cool about the rock cycle is it shows how things can go one direction, but it can show how they go a completely other direction. So we can talk about not just how sediment becomes sedimentary rock, but we can go the opposite way. How does sedimentary rock turn back into small pieces of sediment? So we call that weathering and erosion. So weathering and erosion is simply the breaking down of rocks into the smaller grains, and it's going to do that through rainfall or ice or wind, or we can say snow as well. So it has the word weathering. Weathering has the word weather in it, so we know that's usually going to happen by weather. It's that easy. So those rocks are literally getting broken down until they're down into those tiny pieces of sediment. So here we have some examples of sedimentary rocks. Oh, I have some samples myself. Let me grab them. Here I have, let's see how well you can see that. I'm going to do like a makeup influencer, like on YouTube. Oh yeah, that looks good. So this here is limestone. You've probably heard of limestone. It's that sedimentary rock. You can almost see on a lot of sedimentary rocks the bits and pieces of sediment, those little grains. So that's one good example. I have another example, sandstone. You've probably heard of sandstone as well. And it even has the word sand in it, so you know it's made up of sand. Beautiful. So those are some good examples. Also, one key point that we want to remember. The majority of our fossils, which we just talked about fossils last week, and we're going to keep talking about fossils, all of your fossils are most likely going to be found in sedimentary rocks. So if you've got a fossil, it's probably been buried in sand and dirt, and then it's caught in that whole process of compaction and cementation. lithification, and that's how it's going to become a fossil. So the majority of your fossils, sedimentary rock. All right, let's move on to our next rock type, and this one is my personal favorite. It is the igneous rock. So what is an igneous rock? This is the type of rock that forms when magma or lava is going to cool and harden to become solid. So let's look over here. We've heard of volcanoes. Hopefully you haven't been this close to lava because it's super, super hot and that would hurt. That's kind of scary. But once that lava or that magma cools down, it turns into a hardened structure, and that's going to be that rock. So basically, you've got your magma inside the volcano or your lava outside of the volcano. It's going to cool down and form a nice rock. So what is the difference between magma and lava though? Magma, like I just said, it's still inside the earth. It hasn't really come out of that volcano yet. We can't see it because it's still underneath this volcanic structure. So we call that intrusive rock. I know, I'm throwing more terms at you, but these ones are easy. You know it is intrusive and it is inside of the earth because you see the word inside intrusive. So you see think inside the earth. So that's that magma. So if you hear of an intrusive igneous rock, you know that it was formed by magma or inside the earth. And the opposite of intrusive, which is the lava that's going to be actually outside on the earth's surface, you can see it, that is extrusive. And you can think X like exterior, that means outside, or maybe you can think exit, the exit leads to the outside. So the extrusive is going to be your lava, that's on the outside. So that's your igneous rock. I have some examples of that one too. This one is rhyolite. I think it's nice and pretty. Kind of cool looking. Or this one is obsidian. Maybe you've heard of obsidian before, maybe not. But see, it's kind of shiny. It's just hardened lava. Really cool. Okay, last rock type is the metamorphic rock. Metamorphic. So what's the deal with metamorphic rock? So metamorphic rocks can form from extreme heat and pressure when it's put on existing rock. So basically you're going to have either an igneous rock or a sedimentary rock already formed, and those rocks are going to go through extreme heat or pressure to turn into the metamorphic rock. So what do I mean by that? If you look at this picture here we have rows of rocks already formed. Let's look at this rock right on top of here, and let's say a lot of that hot magma is passing right underneath it. So all of the heat from the magma can heat up that rock that's already formed, and it can cause it to change and shift a little bit and form into what's called a metamorphic rock. Or if you have a rock that is buried underneath a bunch of other rocks, that's a lot of weight, that's a lot of pressure being put down onto that rock. So it can change its shape and change how it looks as well, and it's going to change it into the metamorphic rock. So I've got some examples of that one too. Here we've got marble. We've heard of marble. Maybe marble statues or marble countertops are kind of expensive. Or we've got coal that hopefully you won't get for Christmas. Kind of dirty. So those are your metamorphic rocks formed from heat and pressure. Heat and pressure. Okay, so we just talked about all three types of rocks, and remember, you always want to look and focus at those arrows on the rock cycle, because your three rocks, they're not going to stay the same type of rock forever. So it can go in circles and circles and circles. So you have, let's say, your sediment, and it goes through that compaction and cementation to turn into a sedimentary rock. And then for some reason, that same rock goes through extreme heat and pressure, and it can become a metamorphic rock. But then that metamorphic rock melts down, so it goes through a lot of heat and melts down to form that magma, and that magma can then cool to become an igneous rock. And then that igneous rock can go through that weathering and erosion to become sediments. So it's just a never-ending process, a never-ending cycle. When you're filling out your own rock cycle, which we're going to do tomorrow, spoilers, you just want to think about each rock. How is that formed? We know sedimentary rock, you need that compaction and cementation. Metamorphic rock, that heat, that pressure. And igneous rock, you need that magma cooling down, that magma or that lava. Okay, so that is all I have for you today. It's a lot of new terms, a lot of new information floating around in your head, but I promise you it's going to get super easy with practice, and we'll do that tomorrow. Let me know if you need any help from me.